Hello, in this video I'm trying to determine the volume of the cylinder which is on the top of a hemisphere. For the hemisphere I used an onion slice. For the cylinder I used a chickpea can. Okay, this is not staying still like this, I'm just going to put this beside, but actually I'm trying to determine the volume of the cylinder which is on top of the hemisphere, but for now, for the filming, I'm just putting it beside it. Okay, the hemisphere is in spherical coordinates, obviously. Its equation would be r is equal to 1. And this cylinder is in cylindrical coordinates. So in cylindrical coordinates, x is r cos theta, y is r sin theta, and z is z. And we know r is square root x square plus y square plus z square is equal to 1 because we chose the radius to be 1. Okay. So x is r cos theta, so r square cos square theta plus r square sin square theta plus z square is 1. Cos square theta plus sin square theta is 1. So r square plus z square is, if you square on both sides, you get 1. So z square is 1 minus r square. Z is plus or minus square root 1 minus r square. I would choose the negative square root, not the positive one, because the hemisphere is like this, which is below the x-axis. So for this problem, this hemisphere is below the xy plane, and this cylinder actually starts on the xy plane. So because that's below and not like this, it's actually like this. So we'll take z is negative square root 1 minus r square. Okay, we have everything. Now we can start the problem, like start the triple integral. So remember, to determine the limits of integration, we need to freeze the other two coordinates. Here we have r, theta and z. So let us freeze r and theta to determine the limits of integration for z. So at a constant r and a constant theta, constant radius is a cylinder, constant theta is a plane. So point of intersection would be a line. So how should z vary along this line? Actually, this should be the best placement. How should z vary along this line? So at the bottom part, z follows the equation negative square root 1 minus r square. On the top, let us say the height of cylinder is 5. So on the top, z stops at 5. So along this line, z should vary from negative square root 1 minus r square till 5. And the area element is r, tr, t theta, tz. We determine the limits of integration for z. We need to determine the limits of integration for r. So we had a line there like that. How should these lines vary to cover the entire radius? R is equal to 0 will be the center. R is equal to 1 will be the corner edge. So R should vary from 0 to 1. Okay, we determine the limits of integration for r. We now need to determine the limits of integration for theta. So theta is equal to 0 is this plane here. How should these planes vary to cover the entire surface the entire solid surface that we want? So theta should vary from 0 till 2 pi. We have everything we need now. We can solve the limits of integration. So first, these are the limits of integration for z. So if you integrate dz, you get z negative square root 1 minus r square to 5. So 5 minus minus is plus, because for the lower limit we always need to take the negative of that. So negative of negative is positive, square root 1 minus r square. Now we have r dr, like because these are the limits for r, so I'm only writing r dr. We'll write the d theta later. So that's 5r plus r square root 1 minus r square dr. The integration for 5r is 5r square over 2. R square root 1 minus r square integration is 1 minus r square 3 over 2 divided by negative 3. You can also check this. So 3 over 2, if you differentiate the 1 minus r square 3 over 2, you get 3 over 2, 1 minus r square 1 over 2 minus 2r. At the bottom you have negative 3. So this and this and this negative sign cancel, and you have r 1 minus r square 1 half. So that should be the limits of integration for r square root 1 minus r square, or r 1 minus r square 1 half is the same as square root 1 minus r square multiplied with r. Okay, the limits of integration for radius are between 0 to 1. So if you substitute 1 here, you get 5 over 2. Substitute 1 here, that becomes 0 because 1 minus 1 is 0. Substitute 0 here, that becomes 0. If you substitute 0 here, that becomes 1 to the power 3 over 2, which is 1 divided by negative 3. So the only significant numbers are 5 over 2 and 1 over negative 3. So 5 over 2 minus 1 over 3, or 1 over negative 3. I wrote a minus sign because 0 is for the lower limit. Okay, that gives 5 over 2 plus 1 over 3 and 6. 5 3 is 15, 3 2s are 6 plus 2, 3 2s are 6, okay, 17 over 6. And we have theta here. We did r and z, but we didn't solve for theta yet. So we have the theta, and the limits of integration for theta are between 0 and 2 pi. So 17 over 6 theta, 0 and 2 pi. 17 over 6 multiplied with 2 pi, that gives 2 ones, 2 3s. 17 pi over 3. That should be the volume of this hemisphere and the cylinder. Thank you for watching. Bye.